Okay, people, we're on the Test 3 review for Math 1105, and we're going to look at questions 10 and 11. I'm going to put them both on the same video. What you're asked to do with those two questions, let me read the directions. Find the zeros of each function algebraically. Now, remember what the zeros of a function are. The zeros of a function, by definition, are the x values that cause the y value to become 0. In other words, they're the numbers that you could put into a function that would make the function result in the answer 0. So whenever I say find the zeros of a function, you should be thinking, I'm looking for x. And another thing you should be thinking, whenever you're finding the zeros of a function, you automatically know that y is equal to 0. So let's go ahead and look at the two problems. Let's start with question number 10. Here's the function f of x equals 4x squared minus 11x minus 3. To find the zeros of this function algebraically, we're going to take the function 4x squared minus 11x minus 3, and we are going to set it equal to 0. In other words, we're going to take the expression that represents the function, that's the y value. Okay, remember, this is the y value, and we're setting the y value equal to 0, and whatever x's cause that are called the zeros of our function. Now here's a quadratic equation. It's already in standard form. Let's try to factor it. In this case, I think if we do a little bit of trial and error, I think we can get this expression to factor as 4x plus 1 times x minus 3. Now again, if you're not good at factoring or you're slow at it, then during a test, the smartest thing to do might be to go directly to the quadratic formula. But this does factor. If two factors are multiplied together to give me 0, that means I have two cases. Either 4x plus 1 is 0, or x minus 3 is 0. And I solve each case separately. In this case, excuse me, in this case 4x is equal to negative 1. When I divide by 4, x is negative 1/4. So this is one of my zeros. In other words, if I put the number negative 1/4 into this original function, it would make that y value become 0. And of course, if x minus 3 is 0, then x is 3. So those are our zeros. Now, here's another quadratic function. 2x squared minus x minus 7 is the function. If I want to find the zeros, I take the y value of the function, which is 2x squared minus x minus 7, and I set it equal to 0. Now in this case, this expression, 2x squared minus x minus 7, does not factor. So I'm going to apply the quadratic formula, since it's already in standard form. A is 2, B is negative 1, and C is negative 7. Therefore, x is equal to the opposite of b plus or minus the square root of b squared minus 4ac. And again, remember what I've taught you previously on these videos. When you're using the quadratic formula, plug in. Anything you're plugging in, you should put it in little safety nets. And this is all over 2 times a, which happens to be 2. Now we do our arithmetic. X is equal to, put our line, opposite of negative 1 is 1, plus or minus the square root of, negative 1 quantity squared is 1, negative 4 times 2 is negative 8, negative 8 times negative 7 is a positive 56, and this is all over 4. So we end up getting x is equal to 1 plus or minus the square root of 57 over 4. So the zeros on this function, the zeros of this function are certainly not pretty. One would be 1 plus the square root of 57 over 4. One would be 1 minus the square root of 57 over 4. One thing I always want you to look for, when you're done using the quadratic formula, always look at the square root of this number. If it can be simplified in any way, you should do that. Okay? All right. One other thing I want to point out about the zeros of a function. That function, if you were to graph it, would cross the x-axis at -1/4 and at 3. That's what the zeros of a function represent graphically. This function, if you graphed it, would cross the x-axis at 1 plus the square root of 57 over 4 and 1 minus the square root of 57 over 4. And to make that make a little more sense to you, if you put those two quantities into your calculator and approximated them, that would make a little more sense as to where the graph actually touches the x-axis.